Have you ever wondered how scientists can tell the age of ancient artifacts or fossils? How they can determine how long ago a piece of wood, bone, or even a rock painting was created? Today we're going to explore the fascinating world of carbon dating and the mathematics behind it, with a special focus on its importance to First Nations Australian culture. Carbon dating is a scientific method used to estimate the age of organic materials. It's incredibly useful for archaeologists, historians and scientists who want to understand when certain artifacts were made or when living things like plants and animals died. This process relies on a radioactive form of carbon called carbon-14. All living things absorb carbon-14 from the atmosphere, but once they die, they stop absorbing it, and the carbon-14 in their remains starts to decay. This decay happens at a predictable rate, making it possible for scientists to measure how much carbon-14 is left and estimate how old the material is. This method has been especially valuable in studying the history and culture of First Nations Australians. Carbon dating has helped researchers discover how long ago certain tools, artworks, and even ancient fire pits were created, giving us a deeper understanding of Indigenous history that stretches back tens of thousands of years. So how does carbon dating work in terms of mathematics? This brings us to the concept of exponential decay. When we talk about decay in math, we're describing a process where something decreases at a rate that depends on its current value. In other words, the smaller the amount left, the slower it decays. Exponential decay is the opposite of exponential growth, where something rapidly increases. Instead, in exponential decay, quantities decrease over time in a pattern that creates a curve on a graph. This is crucial for carbon dating because it allows scientists to model how carbon-14 levels decline over thousands of years. Carbon-14 has a half-life of about 5,730 years. This means that every 5,730 years, half of the carbon-14 in a sample will have decayed. So if we start with 100% of the carbon-14 in a piece of wood, after 5,730 years, only 50% will be left. After another 5,730 years, we'd be down to 25%, and so on. This process can continue for tens of thousands of years. Now let's see how this connects to the equations we use in carbon dating. The key to carbon dating is an exponential equation that models the decay process. The equation looks like this. In this equation, Nt represents the amount of carbon-14 left after a certain amount of time. Nat is the original amount of carbon-14. A is a mathematical constant, and lambda is the decay constant that represents how fast carbon-14 decays. By rearranging this equation, scientists can determine how old a sample is by measuring the amount of carbon-14 left in it. This is how archaeologists can estimate the age of artifacts found in Australia, giving us insights into how long ago Indigenous people created certain tools or artworks. For example, carbon dating has helped researchers determine that some rock art found in northern Australia is over 20,000 years old. It's incredible to think that we can use mathematics to unlock stories from so far in the past. The process starts with taking a tiny sample from an artifact, like a piece of wood or bone. Scientists then measure how much carbon-14 is still present. By applying the exponential decay equation, they can calculate the time that has passed since the organism died, giving them an estimate of the artifact's age. Carbon dating is a powerful tool that connects mathematics with real-world applications. It's not just about numbers on a page, it's about understanding history, culture, and the legacy of the First Nations Australians. By applying the principles of exponential decay, we can explore ancient histories, celebrate cultures, and learn more about our world. Thanks for joining us on this journey through carbon dating and exponential decay. Next time you see a piece of ancient art or an old artifact, you'll know a bit more about the incredible science and mathematics that help us uncover its story.